All right, here we go with part 2 of 3.2, Radians and Degrees. This is where we left off. We left off on converting. Okay, so here in this section, we are going to take a look at evaluating trig functions of these radians. Okay, so take notes, evaluating. Again, this is 3.2 continued. No, yes, 3.2. All right. Okay, so when you're evaluating, make sure you reduce the fraction if possible. And I'll explain why that is going to be important. Okay, determine the quadrant. We looked at how the quadrants play an important role in determining the sign of your final answer, meaning positive or negative. Okay, so determine the quadrant and determine the reference angle. So when we first talked about reference angles, we looked at how, oh, okay, well, even though this is not an acute angle, like let's say 150 degrees, right? Uh, and we don't have, that's not one of our basic angles, 30, 45, 60. Uh, it turned out that some of these non-acute angles had a reference angle that was either 30, 45, or 60. And so here, it's going to be the same thing, except in radian form. So determine the reference angle, and it's going to be either 30 degrees, 45, or 60, but now in radian form. So pi over 6, pi over 4, or pi over 3, right? And remember, this one is like your 30 degrees because it takes 6 30 degrees to make 180 to make pi. And this one is 45 degrees because 45 degrees is 1/4 of pi. And here, this one is 60 degrees because 60 degrees is 1/3 of pi. Okay. Pi being 180 degrees. Okay. All right. So what's going to happen here is we are going to be looking at angles that are non-acute angles, but we're going to be looking at them in terms of pi over 6, pi over 4, pi over 3. Okay, so for example, we're going to be looking at sine of pi over 4. We already know that that is square root 2 over 2, right? And we know that, here, let me do another example over here. And then let's just keep going up in increments. So 1/4, 2/4, 3/4, 4/4, 5/4. So 2 pi over 4, oops, I should put sine first. Sine of 2 pi over 4. We'll take a look at that, and then we'll take a look at sine of 3 pi over 4. And then we'll look at 4 pi over 4. And we'll look at 5 pi over 4. And then we'll look at 6 pi over 4. And let's take a look at 7 pi over 4. And then 8 pi over 4. And then we'll end with 9. Okay. and then hopefully you'll get the point. Okay, so we're going to take a look at all of these. Okay, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, and we'll stop at 9/4. Okay. All right, so we already know that pi over 4 is like 45 degrees, so sine of pi over 4 is square root 2 over 2. 2 pi over 4, well, that fraction reduces, right? 2 pi over 4 is the same as pi over 2. Okay, so that's kind of why we should reduce our fractions, because not everything is going to be a fourth. Okay, so now this is pi over 2, which is 90 degrees, right? So we know that the sine of 90 degrees is 1. Okay. All right, so once we get out of that first quadrant, once we are not an acute angle, so now these are all not acute, right? Because now we're going beyond 90 degrees, okay? So to me, it is helpful to draw it so that, look up here, reduce the fraction if possible, determine the quadrant. So that's why it's kind of nice to draw the quadrant, and then we can figure out the reference angle. So here's a hint. Unless it reduces to some other fraction, the reference angle is going to be sort of this parent angle, right? So if this is a fourth, and then we notice, oh, these are all fourths. Okay, so for the most part, the reference angle is going to be pi over 4, 45 degrees, pi over 4. Okay, unless here, unless it reduces to some other fraction. Okay. All right, so this one doesn't reduce. So we already know that the reference angle is going to be pi over 4. So what happens is for all of these, so these are all, let's find the ones that reduce. Okay, this one doesn't reduce. This one does. That one reduces to pi. Okay. This one does not. This one reduces. This one reduces to, I don't know. What does that one reduce to? 3/2. Okay, 3 pi over 2. I should put sine first. Sine of 3 pi over 2. Okay. This one reduces to 2 pi. Okay, and then the rest of these do not. Okay, which means the rest of these here have reference angle of pi over 4. So these are all going to be, so all of these that don't reduce, this one, this one, this one, okay, all of these are going to have an answer of square root 2 over 2. We only need to figure out if it's positive or negative, okay? And that's how it works with pi over 6 and pi over 3 as well. So you can have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 7, 6. Same thing here. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Unless they reduce to some other fraction, they're all going to have this reference angle as this parent angle as a reference angle. Okay. Okay, so let's see. Okay, so over here, so I would draw my circle, okay? And this is fourths, so I would draw my 4 pieces. Okay, top and bottom, because we're going to need more than 4 for some of these, because we're doing more than acute angles now, right? And I would just count to see what quadrant do I land in. So this piece is 1/4. From here to here, that's 2/4. And then from here to all the way to here is 3/4. Okay, so right here, let me get this here. So this is, oh, that, it did not go as planned. Here, hold on a second. Okay. Let me put my lines back in there. Okay. All right. So here, so this here, that's 1/4, that's 2/4, and this is 3/4. So we see that we end up 3 pi over 4 lands in quadrant 2. Okay. So if it's in quadrant 2 and we need to find the sign are the y values, so they're positive here. So this is going to be positive square root 2. Okay. We'll do all of these that did not reduce because we know that these are all going to be square root 2 over 2, right? But we don't know which sign. Okay, so square root 2 over 2, square root 2 over 2, and the same thing with this. Okay, so we need to know what quadrant they all land in. Okay, this one here, 5 pi over 4. Let me get my 4 here. All right, so here, if we do the same thing here, that's 1, that's 2, that's 3/4, that's 4/4, and here's 5/4. So we see that 5 pi over 4 lands over here in quadrant 3. Sign are associated with the y values, so sign is negative here. Okay? And then we do the same thing here with 7 pi over 4. I'm drawing all of these, but you could just visualize it in your head, or maybe just draw the one circle for all the problems. Okay, 7 pi over 4. So if we count here, that's 1/4, that's 2/4, that's 3/4, that's 4/4, that's 5/4, that's 6/4, and here's 7/4. So 7 pi over 4 lands in quadrant 4, right? So sign is negative. So it will be negative square root 2 over 2. And then 9/4, I'm just going to look up here. I'm not going to draw it again. So if I want 9/4, this is 1/4, 2/4, 3/4, 5, 6, 7, 8, 9. So 9 pi over 4 lands back in quadrant 1, and sign is positive. Okay? So if they don't reduce, their reference angle is pi over 4, right? And you can see that. You can see that. So 3 pi over 4 landed over here, and we can see the reference angle is this right here, and it's 1/4, 1/4 pi. Same thing here. So, 5 pi over 4 lands right here. Its reference angle is this piece right here, and we can see it's 1/4 pi. 7 pi over 4 lands all the way over here, and we can see the reference angle, which is this piece, 1/4. And same thing with 9 pi. 9 pi is this right here, and the reference angle is this, 1/4 pi. Okay? All right. So all of these here that don't reduce to some other fraction will have pi over 4 as the reference angle. So it's going to be, they're all going to be square root 2 over 2, either positive or negative, depending on the quadrant that they land in. Okay, so let's take a look at the ones that did reduce to something else. Okay, so what did they reduce to? 2 pi over 4 reduced to pi over 2. Pi over 2 is 90 degrees, and so we got 1. Here, 4 pi over 4 reduces to just pi, 1 pi, and pi is 180, so sine of 180 is 0. Okay. This one here, 3 pi over 2, that's a quadrantal angle. That's 270 degrees. So here, sine is -1. And then over here, 8 pi over 4, that's 2 pi. 2 pi is the same thing as 0 degrees. And so here we would get 0. Okay. So hopefully you have that down, that pi is 180, 3 pi over 2 is 270, and 2 pi is 360. Okay, that was from the previous notes over, where is it? This is from the first video. Here, when we started looking at it here. Okay, is that okay? That's pi. So half of it, 90 degrees, is pi over 2. And if that's 1 pi, then all the way over here is 2 pi. So 2 pi is the same as 360. Okay. And then if that's 1, then over here at 270, that's 1.5. 1.5 is 3 over 2, 3 halves. Okay, so let's get back down to here. Okay, so that's how we got these answers. Okay, pi is 180, sine of 180 is 0. 3 pi over 2 is 270, so sine of 270 is -1. 2 pi is the same as 0 or 360, so sine of 0, 360 is 0. Okay, let's see. The same thing can be said about pi over 6 and pi over 3. So let's just try a few of those. Okay. All right. So let's try sine. Let's do some random ones. We won't go in order. Sine of 7 pi over 6, and let's do sine of 13 pi over 6. And let's do sine of 23 pi over 6. And let's do 16 pi over 6. All right. Okay, so same thing with up above where we did fourths, but now we're doing sixths, which is associated with 30 degrees, right? Okay, so all of these will have reference angle 30 degrees or pi over 6, unless it reduces to something else. Okay, this one does not reduce. This one does not reduce. This one does not reduce. This one does. This last one. Okay, this is the same as 8 pi over 3. Okay, so then these three here will have reference angle pi over 6, which is 30 degrees. Okay, so sine of 30 degrees is 1/2. So all of these are going to be 1/2, except for the last one. We just need to find their reference angle. Okay, all right, so we need to find the quadrant. You know what? I am not going to draw a circle for all of them. I will just draw one right here, kind of in the middle. And I will draw my 6 angles in the top. There's 3 there. Okay. So 1, 2, 3, 4, 5, 6. This one bothers me. Okay. All right. So over here we have 7 pi over 6. All right. So we have to, not that one, this one. Okay. So we want to count 7 6. So this is 1 6. This is 2 6. This is 3. This is 4. This is 5. This is 6. And this is 7. Okay, so 7 pi over 6 lands over here in quadrant 3. Therefore, sign is negative. So here, it's not going to be 1/2. It will be negative 1/2. Okay, and then we'll do the same thing with 13. Oh, this works out because these numbers are all bigger than the previous ones. Okay, so 13. So we already know 1, 2, 3, 4, 5, 6, 7. So let's continue coloring in for all the way to 13. So that's 7, 8, 9, 10, 11, 12, and then 13 over here. So maybe we go darker. Okay, so that's where 13 lands. 13 is in quadrant 1, so sign is positive, so we'll leave that as 1/2, positive 1/2. All right, let's go to 23. Ooh, 23. Okay, so that's 13. I'm going to go darker now with the purple. 14, 15, 16, 17, 18. Are you guys like, hurry up? 19, 20, 21, 22, and 23. All right, so we're in quadrant 4. So again, you don't have to color it all in the way I am. But I'm doing it so that you can have this strong visual when you're trying to do these calculations. Okay, so this one will be negative. Okay. Again, it works just as well if you just kind of count. And you can count in threes or you could count in um, sixes. Okay. Especially if you're trying to get to a high number like that. Very easy just to go, okay, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. You're just counting to see which quadrant you land in, okay? Okay, and this is the only one of the 4 that reduced. So now we're dealing with thirds. And thirds, pi over 3 is 60 degrees. So here, let's count. Divide this into thirds and this one into thirds. And let's just count instead of shading in. So we want 8 thirds. 1, 2, 3, 4 thirds, 5 thirds, 6 thirds, 7 thirds, 8 thirds. Okay, so right here, it lands in quadrant 2. So, and these are thirds. Pi over 3 is the same as 60 degrees. So now it's like you're taking the sine of 60 degrees, which is square root 3 over 2, and it is positive because we're in quadrant 2. Okay? So that's why you have to reduce the fraction if possible, because you might look at this. Sometimes students will look at this and go, oh, 6. So they all have reference angle pi over 6, which is 30 degrees. So the answer is going to be 1/2. Not true. If the fraction reduces, you're not dealing with 6 now, you're dealing with thirds. Pi over 3 is equal to 60 degrees. So that's why this one is square root 3 over 2 and not 1/2. Okay. All right. I think that is it. Oh, let's just do one more because you're going to get some of these on your homework and on the quiz and test. So I want to make sure you can do these. It's not anything big, but it might throw some of you guys off because of the way it looks. So you might be asked to evaluate 3 cosine 2x plus pi. Okay, so that might look kind of crazy, but it's not when we add this part. Okay, when x equals pi over 6. So all you do is substitute this pi over 6 in here for x, okay? And then reduce everything, and it will look familiar to you. Okay, plus pi. Here, the 2 and the 6 cancel. So we have 3 in the denominator. Okay, so then now we have 3 cosine pi over 3 plus pi. Okay, so now I have to add the fractions. Use your calculator if you're not very good at that. Okay, so now this becomes 3 cosine pi over 3. And we need common denominators, so 3 pi over 3. And so now this becomes 3 cosine 4 pi over 3. Okay, so thirds, this fraction doesn't reduce. So thirds are associated with 60 degrees. So 1/3, 2/3, 3/3. Let me get some more down below. Okay. All right, so I need a total of 4/3. So that's 1/3. I'm not going to color them in. That's 1/3, 2/3, 3/3, 4/3. So we are here in quadrant 3. And here the cosine is negative. So this is going to be 3 times negative 1/2, because cosine of 60 is 1/2. So it's negative 3/2. Final answer. Okay, so I just wanted to make sure you guys are able to do this type of problem here, just because it looks a little different. It looked like this. Okay, but it just means that you're going to have to do some arithmetic in there before you do the evaluating. Okay. All right, so that is it. If you have any questions, make sure you text me or email me, or use the um, ask my instructor feature on WebAssign. Okay, I'll see you next time.